Best teachers पढ़ाए तो simple लगे everything. Leaderboards and quizzes से
Amazing.
learning हो जाए happening. समझ आएगा तो मजा आएगा. Vedantu, learn live online. To attend a free live class, download the app now.
Hello everyone, good afternoon. I'm really sorry guys, okay, for taking your 10 minutes because there was serious technical issues. I couldn't come online. Anybody over here? I can't see. Give me a hi. Who are there? Guys, I can't see anyone. Okay, no worries. So once you come online, send me a hi. So I hope you all are enjoying your very fine afternoon, right? So those who don't know me, myself Ameer Basit, Master Teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics. Okay. So today is a very fine afternoon. So, and I know that everyone will be so ready, will be so in a hurry to go for your lunch. But I'm just asking you for your 45 minutes, and I'll make sure that you'll be worth of it. And you must be knowing why we are here. We are here as a part of CBSE Sprint. We'll be discussing about all the previous year questions, chapter wise chapter, to make your preparation so much easier. Okay, and will give you a lot much of confidence also once you go through the previous year questions. Okay, not only previous year questions, you don't have to worry the theory also, because I'm also revising the chapter also whenever we are doing the question. So how the session plan is like, we'll be doing the questions whenever the question is being discussed. I'll discuss all the theory related to that. Okay, and feel free to ask me all the doubts. Okay, and I'll be so happy to answer you all. Okay, all good. So about today's class, we are going to discuss one of the important topic which is having that much percentage in board exam, which is none other than electrostatics. Okay, as the chapter is so important, we are taking two different sessions for covering the same topic. Okay, so we'll be covering the electrostatics in today's session, and we'll also be taking tomorrow's session, so that we can have enough time to discuss all the theories and all the questions. Okay, so I hope all you guys are ready. Yes? Okay, so let's go for the first question over here. So what does it says? A charge Q is moved from a point A above a dipole of dipole moment P to a point B below the dipole in equatorial plane without acceleration. Find the work done in the process. You have to find out the work done, and you must be knowing work done is given by what formula? Work done is equal to, 1 minute. Okay, work done is equal to change in potential energy. Yes or no? Change in potential energy, which means U2 minus U1. What do you mean by this U2 minus U1? The potential energy at the point B and minus the potential energy at the point 1. So let us write it like that itself. Potential energy at the point A minus potential energy at the point B. Okay, so now you have to tell me what is the value for potential energy at the point A. How will you write the potential energy at the point A? That will be equal to whatever the charge you are keeping into the potential at that point VA. And how will you find out the potential produced because of a dipole? That is equal to the potential produced at the point A, which is an bisector, right? So this is a bisector of this particular line, and it is also perpendicular, so you can call it as a perpendicular bisector. So the potential at this point is produced because of this minus Q and this plus Q, and as it is a perpendicular bisector, this will be equal to this. This means the distance, if I am writing it as A, this distance will also be A. And what is the potential produced because of minus Q? That is equal to K Q divided by R with a negative sign, because charge is having a negative sign. Yes or no? Okay. And what about the potential produced at the point A because of plus Q? How much will it be? That is equal to K Q divided by R with a positive sign. Why positive sign? So simple, hai na? Because charge is positive. Now if you want to find out the net potential at the point A, you have to add this, and you know that potential is what? Potential is what kind of quantity it is? Potential is a scalar quantity, so you don't have to look into the direction, just add it like numericals you add. Okay, so this will be added. So what will be the net value? Same but opposite in sign. So once you add it, what will you be getting? It is equal to 0. The same process you can do it over here also, which means you will be getting the potential at this point also as 0. So UB minus UA will be written as Q into VB minus Q into VA, which is equal to Q into VB minus VA. Both VB and VA are 0, so this will be equal to 0 only. So what is the work done in the process? What is the work done in this process? For moving the charge from the point A to the point B, it is completely 0. So you got 1 mark, and this came for which year? This came for CBSE 2016. So understood? Everyone can crack this board exam so easily, so you don't have to worry about it. So let's go for the next question. What is the next question? Read it. Again, it came for CBSE 2015. The question goes like this. The field line of a negative charge are as shown in the figure. Does the kinetic energy of a small negative charge increase or decrease going from B to A? Look, so here you have the negative charge, and you know that for a negative charge the field lines will be always incoming, because it will always be attracting a positive charge. That's why the field lines are inside, right? Yes. So now we are not talking about the test charge is also negative, not positive. So you are having a test charge of negative over here. Okay, so here I'm having a negative charge, another negative charge Q2 I'm writing. Let this be Q1. So here when the body is over here, what kind of force will it be experiencing? What kind of force will this Q2 be experiencing because of Q1? It will be experiencing a repulsive force, right? Always a repulsion happens. So think that if it was having an initial velocity of some V, and when it is in this particular direction towards Q1, in which direction will it be experiencing an acceleration? It will be experiencing an acceleration in the opposite direction to the velocity, right? Or away from Q1. Why? Because both the charges are negative in nature, like charges will always repel. So as a force is in the opposite direction, acceleration, which is equal to force by mass, will also be in the opposite direction. So what can you expect as the acceleration is in the opposite direction when the charge moves from B to A? What can you expect? The velocity will decrease. When the velocity decreases, as you know, what is the formula for kinetic energy? Kinetic energy is equal to half mv square. If the velocity decreases, kinetic energy will also obviously decrease. Simple as that. Again, you scored 1 mark. This was a question came for CBSE 2015. Okay, so this is the reason why I told you will be getting confidence, because when you solve yourself the questions of previous year, you will get a confidence that okay, I did that, why can't I do the exams of this year, right? The same thing can happen. So that's why, and I hope you have understood this particular question. Very simple as that, right? Okay, good. Let's move forward. Next question. Why should electrostatic field be 0 inside a conductor? You must have seen this in many books. Your teachers might also be telling whenever the class is taken, okay, but you might not be knowing why it has to be 0 inside the conductor. Okay, everyone be telling that the electric field inside the conductor has to be 0 in the electrostatic condition, right? Why it has to be? Okay, shall we discuss that? Listen here. So think that, 1 minute, okay. So think that you are having a conductor, okay, a spherical conductor you are having. So whenever you are having a conductor in the electrostatic condition, the electric field inside has to be 0. Do you know why? Because in the electrostatic condition, think that if this particular spherical conductor is having a charge inside, if it is having a charge inside, or if it is having some electric field inside the conductor, what will this electric field will be doing on the charges? Electric field will make this charges to move in that particular conductor, which means the charges will be moving inside the conductor in an electrostatic condition. So what will happen? The electrostatic condition itself will be lost. When the charges moves, what will happen? Current electricity will be produced, or electricity will be produced, which is not our topic. So in the case of in the electrostatic condition, the electric field inside the conductor has to be 0. If it is not 0, electrostatic condition will be lost, charges will start to flow, and current electricity will be produced. Okay, that is why it is always said that the charges on a solid conductor also should be on the surface, not inside. If it is inside, what happens? If the charges of a conductor, if it is inside this particular conductor, what will happen? What will happen is, I hope you know what is Gauss Law. Okay, what Gauss Law says, if you are taking a Gaussian surface, okay, the total electric flux passing through that, Gaussian surface is equal to how much? 1 by epsilon 0 times the charge enclosed. So the total flux. So in the similar manner, supposing that charges are present inside the spherical conductor. Okay, so if you want to find out the total flux at the middle point, what will you be doing? I'll be taking a Gaussian surface. So think that I'm taking a spherical Gaussian surface. Okay, now if I try to write the flux formula, phi will be equal to integral of E dot ds will be equal to 1 by epsilon 0 times the charge enclosed. In this case, a charge is enclosed inside the Gaussian surface, and if a charge is enclosed inside the Gaussian surface, this won't be 0, E dot ds won't be 0, which means there will be a net value of electric field inside. Okay, which is not possible in the case of electrostatic condition, just like I told you before, right? So that is another reason. Okay, that is another reason why the charges of a conductor has to be on the surface, not inside the surface. Understood or what, everyone? So all the charges must be residing on the surface only, not inside the surface. So these concept plays a very important role in electrostatics. Okay, you must be having a very good conceptual knowledge about this. Okay, so I hope you have understood. All good? So let's move forward. So we were doing one more question till now. Okay, so it was easy. I hope you must have understood the concept also. Let's move towards with the 2-mark question, which a question came for CBSE 2014. Okay, so shall we move with it? So the question goes, for any charge configuration, equipotential surface through a point is normal to the electric field. Justify. They're asking why the equipotential surfaces always has to be perpendicular to the electric field. For that, first I must explain what are equipotential surfaces. What are equipotential surfaces? Anybody knows? Anyone knows what is an equipotential surface? From the name itself, we can easily guess what it is. Equipotential, equal potential surface, which means the surface which is having the same potential is called as equipotential surface. So in the case of an equipotential surface, if I ask you a question like this, in the case of an equipotential surface, if I try to move a charge from one point of the equipotential surface to another point of the equipotential surface, should I have to do any work? Should I have to do any work for that particular purpose? The answer is no. Why? Because work done is equal to change in potential energy, and in two cases, once we move the charge from one point to another point, as we are talking about equipotential surface, the potential energy is not changing, or the potential itself is not changing. So as there is no change in potential or the potential energy, there is no work is being done in that particular case. So work done is equal to 0, though that was not our main question. I just gave you a explanation for the equipotential surfaces. So now the question is why it has to be perpendicular. Okay, so think that this is the direction for electric field. Okay, so not this. Yes, okay, so think that this is the direction for the electric field. So electric field is in this direction. Okay, how did you define the potential? Potential is the work done for moving a charge from one point to another point. Yes or no? Yes. Which means if I have a charge over here plus Q, and if I want to move in this particular direction, I have to do some external work. Okay, because against this electric field I am doing. Yes, because always this electric field will try to repel this plus Q, so I don't want to make that happen. So I have to do some work, so that work is converted as a potential energy of the body. That's how the bodies are having the potential energy. Yes, okay. But now look at this particular case. If I want to move the same charge Q in a perpendicular direction, should I have to do any work? Should I have to do any work? If such a question is asked, you should be going to the definition of the work done. Formula is equal to force into displacement. Though I am making a displacement in this direction, should I have to apply any force to make the charge move perpendicular to the electric field? Not at all. Why? Because no external force is acting in that direction, right? So I don't have to apply any force by myself also to make the charge move. So as we are not applying any force on the body, no work is done. So no work is done means no extra potential energy between this point and this point. No extra potential energy. Potential energy difference is zero. If the potential energy difference is zero means these 2 points share the same potential. So whenever we are moving perpendicular to the electric field, all the points are having the same potential. So if we can trace out all the points which are perpendicular to the electric field, we will be getting a surface where all the points in that surface are of same potential value. That is the reason why equipotential surfaces are perpendicular to the electric field. Understood? All good? Happy? Awesome. Let's move forward with the next question which is waiting for us. Okay, so what does it say in the question? A uniform electric field is there which is 5 into 10 power 3 I cap Newton per coulomb. Okay, cap I means I cap. Okay, there was some typing errors, that's all. So electric field is given. Find the flux of this field. Find the flux of this field through a square of side 10 centimeter on a side whose plane is parallel to which plane? On a plane which is parallel to the YZ plane. So electric field is in the which direction? I direction. Electric field is in the I direction and the plane is in the YZ plane, which means both of them are perpendicular to each other. Yes or no? Think that this is the x-axis. Think that this is the x-axis. Okay, and the electric field is present in this particular direction. Electric field is present in this particular direction with the value, and they are asking about a plane at surface. Yes or no? Yes. So they are asking what would be the flux through the same plane or the same square if the plane makes a 30-degree angle with the x-axis. For that you must be knowing what is area vector, because the flux is defined with the formula of E dot A, where E is a vector, area is also a vector. The area vector is defined as the vector who is having the magnitude same as the area of the given surface, and the direction of the area vector is perpendicular to the surface. Okay, it is perpendicular to the surface. So whenever you are having this as a surface, which means I hope you can see, I just want you to give a three-dimensional picture. So if this is the plane and if this is the electric field lines passing, what will be the angle between the area vector? What will be the angle between the area vector and the electric field? Area vector direction is perpendicular to this plane, which means it will be along the electric field line, which means the angle between them in this case is how much? 0. So you must understand that. Okay, so theta is the angle between the electric field vector and the area vector. Yes or no? Okay, all good. So this will be equal to E magnitude, A is magnitude, and cos of the angle between them. Understood? Okay, now what we have to do is, it is given that electric field is making an angle of 30-degree with the plane or with the x-axis. Okay, with the x-axis, if the plane makes an, sorry, it was not the thing, to the same square, if the plane is making, not the electric field, the plane is making an angle of 30-degree with the x-axis. Okay, if the plane is making an angle means, let me draw, think that this is the plane. Okay, this is the x-axis where electric field is going. So it is making an angle of how much? 30-degree, right? So 30-degree is a plane makes with the x-axis, but this theta which is described over here is not the angle between the plane and the electric field. It is the angle between the electric field and the area vector, where the area vector is having a direction perpendicular to the plane. So this is the direction of A cap or the area vector. So if this is 30, how much will this be? This is 90 minus 30, which is 60 degree. So angle between them is 60, not 30. So keep that in mind. this is the silly mistake that you can make from this particular question. This is not tough, but this is a tricky level question to make you or to make your answers go wrong if you are not so good with the concepts. Okay, so we'll put it over here. We'll substitute the values for electric field and the area vector. So electric field is directly given, which is 5 into 10 power 3, okay, which is an SI unit, and area of a square of side 10 centimeters. 10 centimeters means in meters it is 10 power minus 1. So area of a square is a into a, which is a square. So 10 power minus 1, the whole square is how much? 10 power minus 2 into cos of the angle between them is 60. So 10 power 3 into 10 power minus 2 is 10. 5 into 10 is 50. 50 into cos 60 is equal to 1 by 2. So 50 by 2 is equal to how much? How much it is? The answer is simple as that, 25. So this is the only mistake that you can go with this particular question. So I'm asking you, be thorough with the question, which with the theory, then you won't make a mistake in any of the question. Fine, all good. Let's move forward with the next question. Okay. Next question goes like this. Okay, it came for CBSE 2012. The question is, a charge Q is placed at the center of a cube of side L. Okay, you are having a cube exactly at the center, you are keeping a charge Q. What is the electric flux passing through each face of the cube? Now listen, you are having a cube exactly at the center of the cube, you are keeping a charge. So from the charge, the total number of electric field lines coming out of it is given by which law? The Gauss law, right? What does Gauss law says? The total number of electric field lines passing through a Gaussian surface which contains a charge Q is given by integral of, integral of E dot ds is equal to 1 by epsilon 0 times the charge enclosed. Which means in that Gaussian surface, now the Gaussian surface, the surface which is covering the given charge Q is a cube. So the total amount of electric field lines passing out of that cube is given by how much? 1 by epsilon 0 times the charge enclosed. And as it is exactly at the center of the cube, what will be happening? It will be uniformly distributed through all the, how many surfaces are there for the cube? 6 surfaces, right? Or the six surfaces are there. So it will be uniformly distributed across 6 surfaces. Okay, what will be distributed? The value of Q by epsilon 0, which is a total flux lines. So how much will be available for each surface? If this is divided into 6, what will be? As it is uniformly distributed among 6 surfaces, how much will be available with a single surface? It will be equal to 1 by 6 of the total value. Total flux is how much? Total flux is 1 by epsilon 0 times the charge enclosed. So this is the total flux. So each surface will be getting 1 by 6th of it. So the flux through each side, phi of side, is equal to 1 by 6 of Q by epsilon 0. Q by 6 epsilon 0 will be the flux lines passing through each surfaces of the given cube. Yes, good. It was a very good question, right? Okay. So many such kind of arrangement happens. We have discussed only one over here. Don't think that this is the only thing you have to do. Open your book, you will find so many such kind of questions related to finding out the flux and all. Okay, so make sure you are thorough with it and go through the maximum number of questions. Fine, let's jump to the next question. Now we are done with the 2-mark questions. So I hope you have understood which are the kind of 2 marks questions that can appear from the chapter Electrostatics. Right? Okay. Now we are moving forward the 3-mark question. If it is 3 mark, obviously as the mark increases, the importance increases, the difficulty level increases, the length of the answers will also increase. So you have to be prepared in that way only. Go for the first question. 4 point charges Q, small q, capital Q, again small q, are placed at the corners of a square of side A as shown in the figure. Okay. 2 questions are there. Which are the questions? First one is a resultant electric force on any one of the bigger charge Q, and second one is the potential energy of the system. So a very big concept is included in this, not with the first part, the second part. So first part it is easy finding out the force. You only if you are good with the vectors, you can easily crack the first question. How will you do it? They're asking the net force on any of the q, which means let me take I'm taking this particular q over here. Okay, this particular q, let me find out the net force. So how can we do that? So on this, which all charges are giving the force? This particular q, this particular q, and this particular q. As all are positive, obviously it will be repulsive force. Fine. And the force acts along the line joining them also. So keep this in mind about the electrostatic force. So between this and this, there will be a repulsive force, electrostatic repulsive force, given by the value of how much? 1 by 4 pi epsilon 0 written with k, q into q divided by the side of the square is a square, right? Similarly, between this q and this q also, between this q and this q, what you can see over here, again a repulsive force happens along the line joining them. In which direction? In this particular direction. Say, what is the formula again? K into q divided by a square. Before going with the third force, let us find out the resultant of these two forces. If you look at these two forces, what you can see with the magnitudes, both the magnitudes are the same, right? And they are perpendicular in nature. So two vectors in perpendicular, how will you find out the resultant? R is equal to root of a square plus b square. As b is also the same as a square, it is equal to root of 2a square, which means a root 2. What is this a which I was mentioning? The electric field, which means this value I had just written in terms of a only. That's all. This, if you want, I'll write it as a. This will also be a. That's all. Okay, this is equal to a root 2. The resultant of this is equal to root 2 times k q divided by a square. And can you tell me what will be the direction of it? Obviously, it will be in between perpendicular, it will be in the bisector, it will be an angle bisector. Why? Because both the magnitudes are the same. Or if you want to find out in a fashion with angle theta, I'm marking this as a theta, and if you want to know what is the resultant that it makes with one of the magnitude, right? So if this is theta, what can you do? You can take tan theta. Tan theta is equal to opposite side divided by adjacent. Opposite side is also a, adjacent side is also a, which we have marked. So a by a will be equal to how much? 1. So tan theta is equal to 1, theta is equal to 45. That's why I told. So keep this in mind, which means if at all the value is same, which means if at all both the values vectors which are same, the net magnitude which is acting will always be acting in the angular bisector. So it is acting at an angle of 45, as the total angle between them is 90. Now between these two, obviously the line of action of the force will be like diagonal, which means in the same direction of the resultant of these two forces. So it is in the same direction, you can simply add up the values. But you have to know what is the value between the, or what is the force produced between these two charges. How much it is? K into q square divided by what is the distance of the diagonal. You can use Pythagoras theorem, right? A, this will be equal to root 2a. I hope you don't have any doubt in that. Root of a square plus a square root 2a, and if you square it, that will be equal to 2a square. So this is the value for the force produced because of this in this particular direction. You can simply add up the values. So F net will be equal to, I'm writing it as root 2 k q divided by a square plus k q square by 2a square. So what can I take common? K q divided by a square. If I take it as common, what is remaining? Root 2q plus q divided by 2. Simple only, right? I hope you have understood. It was a very simple question also. Yes. Now the second part plays a very important role, which means the second question. So this was the answer for the first part. The second part, the potential energy of this particular system. So how will you find the potential energy of this particular system? how the potential energy is built in a particular system? Because we are doing some work in that system. So when we have to do some work, because if an electric force is happening, or if you want to apply some external force against some force, we have to do some work, right? So there comes the work done, and if work is done, potential energy is produced. Okay, now they are asking what is the value for work done in this particular case, which means if you want to bring all the charges from infinity and keep it like in the form of a square, how much of work has to be done? So what will you be doing? We'll be taking the charges one by one, and we'll find out the work done for each of that particular process, which will be equal to the potential energy, right? So starting from the first charge, I am bringing the first charge of small q. Okay, so let me clear this off. Okay, we'll be doing it here. I'm clearing this first part out. Okay, it is over here. So let me clear it out. Okay, listen. So the potential energy of the system, right? Okay, let me do that. Let me draw a line. This comes for the previous one. So it was like this, right? Which means a q over here, small q over here, capital Q, capital Q. So as we are finding out the work done, I am bringing the first charge of small q, where no other charges were present. If no other charges were present, when I was bringing this small q to this particular point, should I have to do any work? Absolutely not, because I don't have to apply any external force, because there is no other charge present during that time to produce an electric field. So as I'm not doing any work, no potential energy will be stored inside. So I have brought the first charge, right? So I have brought the first charge, so the first charge is over here. Now when I am bringing the second charge to this particular point, I have to do some work, right? Okay, so how much work I have to do? Which is equal to the potential difference between the points. So from where I am bringing this particular q, from infinity I am bringing this charge q to this particular point. So work done is equal to change in potential energy. Okay, so the potential energy of this particular system is equal to the work done for bringing the charge from infinity to that point. So what will be the work done? It is equal to k into qq divided by the distance is how much? A. So kq by A. Right, now these two are done. Now we are bringing the third charge to this. If I am bringing the third charge to this particular system, I have to do a work against this capital Q and the small q also. If I am doing some work, it will be stored as a potential energy. Potential energy will be given by the same formula of potential, right? The potential that you have to, that will be produced because of the charges. What is the value for bringing this q from infinity to that point? It is the potential produced because of this q at this point. How much it is? K into qq divided by A, plus against this also you are doing the work, so because of that also there will be a energy. How much it is? K into q square divided by, what is this diagonal distance? It is root 2a, right? A, so root 2a. So we have took 3 charges from infinity to this point. Now I have to bring the 4th charges to this particular point. So once I am bringing the 4th charge of capital Q to this particular point, I have to do the work against this, I have to do the work against this, and I have to do the work against this. So potential energy will be produced because of all these 3 things. Okay, so will be equal to how much? First we'll write with this potential energy produced against this particular Q, that is K qq divided by A, plus against this k q square by root 2a, plus then against this k into qq divided by A. So if you add up all these values, you will be getting the net value of potential energy. Are you clear? So now what is left? Only the simplification is left by taking out the common values. Okay, what all are the common values? K is there, divided by A is there, right? So I hope K divided by A is there. Inside what will be there? How many KQQ divided by A is there? 4 times. So 4 times KQQ plus, then what is there? Then you can have 1 Q square by root 2 plus the other one is Q square divided by root 2. Yes or no? So this will be the net value of potential or the potential energy of this particular system. Guys, I hope you have understood this. Yes or no? So same thing is written over here also, this value. So I think you are happy. I think you feel like you have benefited something from coming to the class. I think some of your theories are revised. Okay, so some questions you were able to do. Okay, if you have done all these things, this is such an awesome thing for me and also an amazing feeling for me, right? So I know that if you are doing all these stuffs, okay, if you are doing all these stuff, which means coming to these classes and all, which means you need or you are lacking some of the theories, or you don't know the method by which how to proceed with the preparations, right? So don't worry about it. Vedantu is here because we already have the JEE crash course which is already happening. What do you have to do? Just come and join the JEE crash course. What is happening there? You will be having the live courses. Classes will be there, and whenever you miss some of the classes, don't worry at all, because it will be recorded and you will have the access to all the recorded versions. People will be there to give you assignments to make you more stronger. Okay, everything will be provided. And what do you have to do? You just have to spend an amount of 9,500 rupees for joining the JEE course. Go to this particular site which you can see over here. I'll clear this out. Okay, you can see this link over here. Go to this link, and on this link apply the code AMECC, where you will be getting this once you apply this coupon code, you will be getting this particular course just for 9,500. Spend 9,500 and make your future really awesome, right? So guys, I hope you have liked the classes. If you have liked, please click the like button, and if you think that this class was awesome and this could also be benefited your friends, share this particular video and don't forget to subscribe so that you'll get the notification of all the classes which is happening in JEEs. Okay, so guys, bye till we meet next time, and enjoy your afternoon with a sweet awesome lunch. See you soon. Bye.